Hi everyone, my name is Abhay, and today I'm going to be talking about security automation. And specifically, I'm going to be talking about automating application security with something called the robot framework. Now, I'm sure all of you are wondering why automation and why are we so concerned about security automation. So, I'm going to start off with a little bit of a preamble. I'm going to talk about what are the current problems with application security? What are the major burning issues in the world of security? And then I'm going to talk about how we can automate some of this. Wouldn't it be great if you could go ahead and just automate some of these tasks that you were otherwise doing manually and spending so much time manually? Wouldn't it be great if you could automate that? Well, I'm going to be talking about how you can automate some of these tasks with something called the robot framework. And then I'm going to actually create an automation or security test automation with Robot Framework and demo it right in front of you so that you can understand how you can use some of these libraries and tools to build your own automated pipelines for security with the Robot Framework. So let's get to it without further ado. So let's talk about DevOps, right? Now, if you look at DevOps, I'm sure all of you have heard of this term DevOps, and I'm sure all of you have heard of software automation and DevOps, and these terms have really taken over the world, especially DevOps, because what DevOps has done is that it has bridged two completely different entities. Previously, when without DevOps, what used to happen was developers would write some code, package it in whatever binary they would, pass it on to the ops folks to go and deploy on servers. The ops folks would go and deploy naturally on the servers, and then figure out that there's this dependency missing, or this software package that has not been properly installed, or something does not work, and as a result, the entire deployment would go kaput. Now, this is for a large organization or any organization that is deploying software. This is a huge problem simply because they are not in a position to take that kind of risk, especially with development and operations, because they want things to run smoothly. And over time, we've seen a movement where software is deployed multiple times a day. For instance, let's say you're a large e-commerce company like Amazon or whatever, you are going to be deploying software all the time, and you're going to be making changes to your application all the time. If you have to deploy or rely on manual processes to bridge dev and ops, then it becomes really complicated. That's why DevOps really started off as a movement to bring these two disciplines together in the form of a culture, which has also led to a lot of automation, a lot of automated solutions that makes things life much easier for companies that build applications, right? So, and today every company builds applications, so that's not really something that is only reserved for a specific set of companies. Now, with DevOps, what is really happening is that automation is taking over the world. Developers would just write software, and then it would kick off a bunch of automated tasks like running the integration tests, the unit tests. They would run a bunch of other performance and maybe functional tests, and then once they would run it, they would deploy the code in servers or different server environments, and then that would be subjected to further testing before it goes finally to production. A lot of companies do this 10, 20 times a day, a lot of times, because they want the latest and greatest of features reaching their users as soon as they possibly can. So that's why DevOps has really been a huge boon to the industry as a movement and as a technology paradigm. However, there's one major component of DevOps that is still, I wouldn't say missing, because it's not missing in all organizations, but missing in a large section of organizations that do DevOps on a daily basis, and that is security, right? If you look at security, it's probably one of the most important things, right? When you are doing something that fast, or when you are doing something that automated, you want to make sure that security is built in. And security is not easy to fix. If you look at these statistics from the System Sciences Institute of IBM, you'd see that these statistics are no joke. For instance, when you have a bug in the design phase or the implementation phase, it costs you 6 times to fix the bug. But once that bug goes into the testing phase, it costs 15 times the amount or the resources that it would take to fix. And once the bug goes out there to production, that is completely asymmetrical in terms of cost. You can see that 15x becomes 100 times the amount of effort or resources you would spend in trying to fix those bugs once they go out to customers and once your application is being used by customers and potentially hackers as well. So it makes a lot of sense to identify and find security issues and identify security issues early on in the life cycle. And that's why you need to be finding security issues early on in the life cycle. Security issues are nothing but other bugs. A lot of people think of security issues as this mythical, complex creature that is sprung from the wild, but it's not really the case. Security is just another bug. Just like any other software bug, security is just another bug. So that's why you want something to be identified as early as possible in the life cycle and not later as it moves closer to production. So in short, what's happening today is this, right? We have application delivery and software deployments happening at a rapid pace, and they're going really, really fast and really, really efficiently, whereas security is still done as a last minute thing. Now, in most organizations, and I work with tons of organizations in a month, and what happens is that security is always done just before they go live. And when that happens, one of two things could happen, right? The security review could come back with a lot of findings, and then they would decide that, hey, you know what, there are too many security issues, let's delay this release. And that would cause a whole lot of issues with the development team. They worked really hard on building this product, and they've had to push the release and still sit on bugs and fix more bugs forever and ever and ever. And that would be very, very morale depleting for a lot of folks. The other option that a lot of companies take is they say, hey, let's just go and release it, let's deploy it to the wild, and then figure out how we go from there. That's equally dangerous, in fact, more dangerous, simply because at that time, you don't really have control over what's happening to your apps in the real world. Hackers could understand that, oh, you have this SQL injection flaw or this command injection flaw, and then exploit it and steal tons of customer data. So these two options are being caught between a rock and a hard place, and that's why application security should not be done as a last mile task. It should be incorporated into your development and delivery process. Basically, we need to find security bugs early and often. We need for security to integrate with your development processes, and we need for security to work very smoothly as part of your delivery pipeline. So think of your software development process as a pipeline or as an assembly line. You need security to work seamlessly with that assembly line. So if you look at security in the software development lifecycle, or the SDL, this is what I'm talking about, right? I'm not talking about security done at the last stage of your SDL. You need security at each stage of your process. And this gives you a simple insight into how you could do that. On top, you would see a bunch of, the standard SDL activities: plan, code, build, test, release, deploy, operate, and monitor. These are the typical activities one would see in a software development lifecycle. Below, you would see a list of activities that you should be performing as a security activity in each of these steps, or in a bunch of these steps. So during the plan phase, you should be doing something called threat modeling, where you would be able to identify or do a scenario-based analysis of what kind of threats or what kind of attacks could happen against your application, and build safeguards for it right at this phase, right? So as you're planning to build software, you should be able to identify security issues with that software. That's great, right? Because the software security issues don't even go to a point where they would need to be identified. There would be safeguards and mechanisms built in. And once the developer starts coding the application, building the application, you need to be running static code analysis and source composition analysis. So static code analysis is a practice of running source scanners or source code scanners against your source code to identify, hey, this line, or you've been using an insecure call to call your database on line number 49. Or you've been using an insecure library on line number 54. Now that would give the developers immediate feedback to go ahead and fix the security issues right then and there before they even go to production. So we do two steps in this phase, which is running static code analysis tools and source composition analysis tools. Now, both of these are important, especially source composition, because what happens is that most of us never write truly original code, right? We always write code that where we are importing libraries and importing third-party libraries and software in our product. Now, a lot of times, third-party developers, just like all of us, make the same set of security mistakes. So you need to know whether the third-party library that you are using is vulnerable to some security flaw, right? So that's when you run composition analysis, and that's what composition analysis is all about. Now, once the developer has written the build and or written the code and it's been built, you go to the testing phase. So typically, this would be when your performance functional testers would be invoked in order to run a set of tests. At that time, you need to run a runtime security test against your application. And that's called a DAST, or dynamic application security testing process. There is also another piece of technology called the IAST, or the interactive application security test, where it's instrumenting the app and running the test. But either way, what we are trying to do at this phase of the SDL is trying to run a runtime security test. We're trying to see what the hackers see, right? Once we deploy the app, hey, what do the hackers see in our application? How do they find flaws? So this is the phase that would try and tell you how you should be running some of this stuff in the dynamic part of the testing phase. Once you're done, you need to make sure that your deployment is secure, and that's when you want to secure your infrastructure. So you would also need to run security scans against your infrastructure as code, and once you deploy the app completely, you need to be monitoring for security threats. You need to be monitoring for any attack attempts and attack detection that is happening. So as you can see, we're not relegating security to a gatekeeper process or an end process. We're making sure that security has been built in throughout the SDL, and we're making sure that security is taken into consideration at different steps of the SDL. Right? So let's talk about the robot framework and why we are so why I am so excited about the robot framework. Right? Now, one of the big challenges in any security automation is trying to do it in one set of steps or in a sequential set of steps. Security products are complex. A lot of times they don't have very good integrations built in. So a lot of times they're very difficult to invoke in terms of automation. So you need something that makes things easier for everybody. That's why the robot framework was so great when I saw it. I started using the robot framework about a year ago, and I've still been extremely fascinated by some of the features that they have and some of the things that you can do with it. So let me talk a little bit about the robot framework and how it can help you. So one of the things with robot framework is that it is a generic test framework. So if you have seen other test frameworks like Selenium, or if you've seen other test frameworks or test automation frameworks like Mocha or Chai or whatever, what they do is they run tests. So they have a test library where you would specify, hey, I need to test this or that or whatever else, and they would run those tests. Robot framework is very similar to that. So it runs tasks or tests, right? The great thing about robot framework is that it's multi-platform. So it's not only JavaScript. It has Python and Java libraries. It has both. It doesn't have more than that, but right now Python and Java, since they're pretty popular in the testing world, these are very useful to have in terms of multi-platform support. You also have a highly modular structure. You'll see this when I get into the demo, is that one of the things that Robot Framework brings with it is a highly modular architecture where you can run tests independently and you don't need to worry about one affecting something else. One of the big problems when you're testing something is one part of your test unnecessarily interacting or causing problems with another part of your test or other segment of your test. And that's what Robot Framework tries to avoid, and it makes it very, very modular and very, very specific to that execution point. And the other great thing, and all of us love this, is reporting, right? One of the worst things that you can have is after you run all of these tests to sit and report some of this manually and go through some of this manually. That's a real pain. I understand it because I write pen test reports for a living. It's a real pain to do that. So this has a lot of reporting tools built in manually that auto-generate reports as soon as they're done in terms of the testing process. So that's great. That's always good to have, right? And it's open source. In case I didn't mention, Robot Framework is completely open source. And if you look at it in the application development world, if you see software robots or robotic type of implementations are everywhere, right? Any of these tools, you're talking Ansible, Kubernetes, serverless, Packer, CloudFormation, all of these are spec-like frameworks where the developer or the person writing the spec can define a set of tasks or a set of processes that these tools need to do, and they run these particular set of tasks against whatever environment they're configured to run it against. For instance, if I do serverless, I would deploy an application to a serverless environment and make it ready for serverless deployments. Or if I use Kubernetes, I would use container orchestration, deploy containers, manage the container lifecycle very, very easily. Or CloudFormation or Terraform, whatever. They allow you to define a specification and run that specification to perform certain tasks. So that's where software robots. So this is not a new concept. This is just a concept that's being applied a little differently for security. And robot framework can run any library. You really just have to specify the library, and it can run pretty much any piece of code under the hood. So the way it works is that what it does is that the tester writes the test. So you need to code the test in robot framework. It's not just something that would, at the click of a button, automate everything and move on. You need to write some test information or set of tasks that it needs to run, right? Now what the framework does is that it parses this data. And once it parses this data, it looks at the keywords. Now robot framework is built on keywords because one of the big selling points or USPs of the robot framework is that it does not need you to write codes per se or any kind of specific application development. You don't need to be a great coder to write robot framework. You need to know those keywords. And a keyword is essentially like a task definition. Hey, open browser, for instance, is a keyword. That would open the browser naturally, right? Or go to this link. That would open up the browser and go to a particular link. That's simple. So what it would do is extracts all those keywords from the test data and checks whether those keywords are available in the libraries that you've called them against. And then the libraries would run those keywords. So let's say open browser, the library would actually contact your operating system, figure out that there's a Firefox browser there, open up the Firefox browser and run the Firefox browser. So the library would communicate with all the necessary parts of the system that are working with those tools and then invoke them at the time they're called, and it would give you a pass-fail result. So once, let's say open browser is a test. So if open browser successfully works, it would give you a pass. If there is some security issue or some other kind of exception that comes up during the open browser process, it would give you a, hey, no, fail, this didn't work because of this exception or this error that your operating system threw. So robot framework just runs libraries. It's a test framework that allows you to just specify certain libraries and keywords, and you could run it very easily against those keywords. Why I like it? The reason is you don't really have to code. One of the big reasons I like robot framework is that it is available and it can be used by anyone. If you are motivated enough to use it, it's very, very easy to do. You just need to know the keywords and how to use the keywords. You don't really need to know how to code, and you'll see that when I'm doing my demo as well. And if you are a developer who's writing libraries, robot framework is very easy to build libraries on top of. So let's say you want to build something for that to run a particular automation to do certain. Let us say you're a bank and you need to write an XML parser and you want to run this as a regular job all the time. You can use a robot framework library or build your own robot framework library. Very easy. It's modular. It runs as specific tasks, and each task does not affect each other unless you want it to. So it's really, really nice, because a lot of times automation fails because one task would not work, and the concomitant tasks, there is no real concept of separation in a lot of test frameworks, and that causes a huge challenge. But robot framework is completely modular and it makes things much, much easier. Like I said, it comes with reporting out of the box, and of course Python and Java support. Both of these are languages I use, especially Python, so it's got a great deal of support for Python, which is why I love it. So I'm going to be showing you a demo that talks about these two things. We're going to be running SAST, which is Static Application Security Testing, or Static Code Analysis, Security Composition Analysis, and we're going to be running a small runtime test against our environment and generating a nice little report at the end of the whole process, right? So that's what we're going to be doing in our demo today. So our demo is essentially going to have these processes. So we're going to pull some code from GitHub, which is an intentionally vulnerable app that I have created for this purpose. Then we're going to run static code analysis tools, which would identify security issues in the code itself by running it against the source code that you've pulled from GitHub. Then we would check dependencies. We're going to be using the very easy to use npm audit, which is for Node.js. So this is a Node.js app that I'm going to be running it against. So we're going to be checking Node.js dependencies for security issues. And once we're done, we're going to be using a dynamic scanning tool called Zap to find runtime vulnerabilities. Now, Zap is from the OWASP Foundation. It's a free open source open source tool that you can use for this. All of these tools that I'm going to be using in the pipeline today are open source. The libraries are open source. They're available at my GitHub repo to download. You can just use the example and download the example and start getting up and running immediately with your automation process. Right, so our demo is going to be like this. We're going to pull some code from GitHub, run static code analysis on the code base to find vulnerabilities with the static code. Then we're going to identify security issues in the libraries, the third party. So I've imported a bunch of third party libraries. We're going to see what kind of security issues those libraries have. And then we're going to run some dynamic scanning to identify runtime vulnerabilities in an application. All of this is going to be done in an automated way. That's the most important thing, right? All of this used to be done manually. It used to be done with a lot of people having to put in a lot of time to do this. But this, to be honest, you can do a lot of these activities in the pipeline or in an automated way. And that's what we are trying to leverage to make things faster for our own security processes. And that's the end of the demo. All right, let's get to the demo. Now, in this demo, I'm going to show you how you can build a security testing pipeline with the robot framework. And I'll walk you through the demo, and then we will actually execute the demo and you'll see how it works. So this is how a robot script works, robot framework script works. Every one of these items, let me just get into and then talk about how they work in tandem. So think of any robot script just like any other piece of source code or any other piece of code you would write. You have a bunch of libraries that you would import, which is in settings. You have a bunch of variables that you would use throughout your test. And you have test cases or tasks, if you want to think about it that way. So each of the test case has a name and has a bunch of keywords associated with that name. Right? Now these keywords refer to some library or the other in which the keyword is being invoked. For instance, this keyword, run Node.js scan against source, refers to a library called robo Node.js, which actually has this keyword. So let me just show you that library as well, and you'll have a look as to how it looks and what it actually does. So let's go to robo Node.js and you'll see what I'm talking about. You will see that run Node.js against source is actually a function in this library. So what a robot does is that this particular function, it just separates the underscore values and this becomes a keyword. So it looks for this particular keyword in this library and executes that particular function with all the function arguments. So in this case, what you would need to run Node.js scan, which is a static analysis tool, against the Node.js source code is a path from which it uses the source code and it scans this particular path. This is where the source code is stored. It scans this path and writes results to a results path. Right? So each keyword has a meaning or it has a associated function in some library or the other. So for instance, we are doing a bunch of tests for the SSL and TLS deployments, and these are all in a library called robo-SSLIs. And robo-SSLIs, all of these, by the way, are open source libraries. Most of them have been written by me. You can use it open source. Some of them have been written by others as well. So there's a large community contributing to the robot framework through external libraries. I'm one of them, and my company is one of them as well. So we write a lot of robot framework scripts. So SSLI. So for instance, one of the keywords is test SSL basic, and if you go to robo SSLIs, you will actually see a function called test SSL basic, and you need to provide a certain information about that particular, the arguments for that particular function. So all of this is run. So what we're doing in this, as I mentioned as part of our process, is we're going to pull some code from GitHub. So you can see this. We're going to run a static analysis tool against the code. Now this code, remember, is in Node.js. It's a Node.js application. You're also going to run npm audit. Now npm audit is a new feature from the Node Package Manager organization, which actually identifies security flaws against your third-party libraries that you're using in your Node code base, which is great, and it's a very nice tool that you should be using if you're running Node.js apps. Then what we're going to do is test the SSL deployment on our server. So I'm running two versions of the deployed instance of this application, one on my laptop and the other on a server out there somewhere. Then I'm going to, this is a web service, so I'm going to start up OWASP Zap, which is a vulnerability scanning tool for apps. And I'm actually going to authenticate. The reason I'm authenticating to the app or the web service is because if I don't authenticate, there is no real point of actually performing the test, because you would only be able to test it as an unauthenticated user and you won't find too much by way of that. So I'm going to authenticate and perform certain operations. So I'm going to authenticate to this web service, and I'm going to get an authorization token. This authorization token I'm going to be using in all my other requests. I just have one more request just for this demo, because this is a very quick demo that I want to show. And each HTTP request I send to the web service, I need to append this authorization header with the token that I have received when I authenticate to that particular web service. Once I'm done with it, I start an active scan and I write all the results to the database and so on. So this is actually as you can see, you don't really need to write code for this. You just need to invoke specific keywords at specific junctures, and you will be able to actually run an entirely automated security pipeline. So why don't we just see this in action, right? So all I need to do is, in my directory, I have this robot script, and I'm going to call security test.robot. And you'll see how it works in a little bit. Now, each of the security tests are executed as singular tests. So you have a pass, fail, all of that stuff happens. So if it's not able to execute something, it fails the test. So in this case, it has failed something for some reason, but nevertheless, it's running. It does not mean that the rest of the tests fail. It does not mean anything like that. So as you can see, it is running all of the tests. It pulled the code from GitHub. It ran Node.js scan. It tried to run npm audit, but there was some error in the process. But now it's running OWASP Zap. I'm just going to open this up, and you can see how OWASP Zap is running in the background. It accesses the application. It's going to authenticate to this application, and it's going to start running an active scan pretty soon. So I'm going to just, so that you can see that the active scan is running, and it should find one or two flaws against this particular application, hopefully. Based on what you do, it should find one or two flaws against this application. So what it does is that it runs the entire flow as a pipeline, right? So think of it. So if you're familiar with continuous integration or CI/CD pipelines, you would see that it runs similar to that. And it found a SQL injection bug. So it found a MySQL SQL injection bug that only authenticated users would have access to if they were accessing this application, which is great, right? So without even executing any manual effort, you are able to completely automate your security pipeline, because you are calling so think of it as a recipe, right? So what we're doing is we're just creating this recipe and deploying or invoking this recipe again repeatedly. So a lot of time is saved for engineering teams. Engineering teams can actually run their own security without too much difficulty with the robot framework, and it makes life much easier for all concerned, simply because they can just run independently of the security team, or the security team can most of these scripts, right? You don't really need to run manual efforts again and again. Makes it so much easier for you to be able to actually scale your security program when you run it in a completely automated way. So I'm just going to wait for the script to end, and you'll see that the script ended. Of course, we had one failed test, which is fine, but everything else is passed. It's written the report, and I'll just show you what has been written in the report. It's right here. I'm just going to, so it writes, I've written a program that writes a report, but all of the evidences are stored anyway. So this is the ZAP report, this is the Node.js scan report, which is the source code analysis report, which is written in JSON. The NPM audit report has also worked, or weirdly it has, I don't know why it failed however, but it has actually worked, it's found the issues. And it also writes a markdown report, which is much easier to read. Let me just show you how this looks. We're going to open it up with our markdown reader, and you can see that it has actually found all the vulnerabilities, including the vulnerabilities for the Node.js scan, as well as ZAP and so many other issues, and also the SSL flaws have been identified. Now this is great, right? You don't really put in any additional effort, but you're actually getting a high quality testing report with a bundle of tools, actually relevant tools and contextually driven tools to identify security issues and come out with findings in a completely automated way. So let's quickly summarize what we have learned today in this quick lesson. So one of the things that we saw was that current security approaches are very manual, right? They're extremely manual, and they are highly dependent on manual efforts, which makes it a big bottleneck in a fast-paced application delivery pipeline. And we see that a lot of times because of this, people tend to get left out of the application delivery pipeline. Security tends to get left out of the application delivery pipeline. So we need something to scale. We realized that automation is one of the ways we can scale with things. While we may not be able to automate everything, we should automate what we can automate. And definitely some of the tools like static analysis, source composition scanning, DAS tools you should be able to automate it in a reasonably efficient way. So we need something scalable, and we need to run it at different parts of the life cycle. Robot framework, as we mentioned, is an automation framework that helps you do that. It's a generic automation framework, and you can give it any library that has certain functions which it uses as keywords, and it runs these functions as soon as they are invoked with the right arguments with the right keywords. So robot framework is very easy to help you scale. It's actually being used by a lot of testing teams all over the world, so it's getting more and more popular. In fact, it's one of the more popular tools in 2018, and I think it's gaining in significance because of its ease of use and natural language syntax that does not require you to run or write any code. So you can create your own API. Like I said, you can see how easy it is to create API. You can just write your own API with the functions which are invoked as keywords, and then performs a set of tests. So what we explored today was a completely automated security pipeline. I hope you found this to be a useful session. Thank you very much. Bye-bye.